Welcome to the CCNA course presented by Smart Tech, Lesson 3, Networking Fundamentals, Part 2. As you know, we will continue with our free CCNA 200-301 training course, which started by Cisco in February 2020. What is a router? A router is a networking device that connects two or more different networks, LANs, together. It can forward data packets between the different computer networks and perform traffic directions on the internet from one network to the other. There are many types of routers depending on their capacity, transmission speed, types of interfaces, and technologies used. Router types can vary from huge routers that have huge data processing capabilities and huge capacities that are used by the ISPs, Internet Service Providers, to transfer the huge data traffic over the Internet, to the small routers which are installed at home or small offices to provide the Internet services to the end users. So, routers are hardware devices, sometimes can be software also, that have the following features. First, provide data connectivity between different networks, different LANs, WANs. WAN means wide area network. And that's why routers are used to send the data over the internet, because they interconnect different networks together. There are many types and sizes of routers. Also, usually they have less number of interfaces than the switches. Again, let's go back to our network to see how the data will flow between the two branches. If PC1 in New York requests a record of an employee from the server 1 at San Francisco branch, then this request will go to R1 through switch 1. Then R1 will check the destination address, the IP address. What is the IP address? Each device on any network should have unique address, and these addresses are recorded in centralized servers in the world, which is called ICANN, ICANN, Internet Corporation for Assigned Names and Numbers, and its division, the Internet Assigned Number Authority, IANA. These are non-profit private American corporation that oversees global IP addresses allocation in the world. This organization is specialized only to identify the addresses and their locations in order to deliver the required connection for each PC in the world with any other PC at any place. Let's go back to our example. So, if router 1 finds the destination IP address is not from his local IP addresses in the LAN, then it will forward this request to the outside internet router. And each router on the internet will keep forwarding this data packet. Each data packet has source IP address and destination IP address to know from where it is generated and to which destination it should reach. So, the internet routers will keep forwarding the data packets from one router to other until it reaches to R2 in San Francisco. Then R2 will check this data packet. If the destination IP address related to one of its local addresses, then R2 will pass the request inside its network to PC2 through switch 2. Then PC2 will send the required employee record number back to the PC1 using the same techniques and same rules. Now, After we built our network using the switch, then connected it to the internet through the router, our network became exposed to the internet, and we can access our PCs from anywhere in the world. Although this is a very good merit we are getting from the internet, nevertheless, this may lead to other big issue, because not only authorized people can access our PCs or servers located in New York or San Francisco offices. However, anybody connected to the internet sitting at any place in the world can also access them, and may cause harm by erasing important files or information, or even get unauthorized access to personal information which nobody should get, or may even destroy valuable data. This person called hacker. A hacker is a person who may secretly access other networks which is unauthorized to access and make damage to this network. So, to protect our networks, we may need another device used for protection called firewall. A firewall is a special device that monitors and controls the data traffic coming inside or going outside the network to allow or deny passing the data in either ways. Depends on some criteria or rules. Firewall usually deployed at the entrance of the network, before the router, or between the router and the switch. Firewall should be configured with security rules to control which types of data traffic is allowed and which ones are denied to enter or exit the network in either. So, data traffic from PCs from New York to San Francisco branch and from San Francisco to New York branch should be configured to be allowed to pass in both firewalls, Firewall 1 and Firewall 2, while denying the traffic coming from outside PC that doesn't belong to these two networks. Moreover, Firewall also has other feature which may grant the access for a PC to log in from outside these two networks using a special authentication software or special technology called VPN, Virtual Private Network, which means that the person which is sitting outside these two networks, physically connecting from outside location over the internet, but virtually considered that his PC is one of the inside PCs of one of the New York network or San Francisco network. This person can connect using the VPN client software installed in his PC and also installed on the firewall. The connection between the PC and the firewall will be completely encrypted by the VPN algorithm, and all the data will be safe using special encryption formulas. Only the firewall installed in a New York or San Francisco office can understand how to decrypt this data and allow this client PC to access the private data inside New York and San Francisco offices. Other than these cases, any other PC tries to access the networks from outside considered as hacker, and its access is denied to go through the firewall. There are different types of firewalls. Some of them sometimes are called next generation firewall if they have many advanced security features like IPS, intrusion prevention system. Firewalls are hardware devices installed for enterprise and medium-sized networks. And for normal users, there are some software firewalls usually installed on their PCs to provide basic security protection. Now, let's take a look at a small office network. We can see that it consists of most of the devices that we described earlier. Here are the firewall, router, some switches, some servers, PCs. We can find also network printers. If we look at the PCs and servers, we may see them from the different brands. Also different types of OS, operating system, like Windows, Linux, Mac OS, and many other types of OS. The switches and routers may be from different brands also, and different operating systems. We may see some smartphones connected to the same network through wireless access points, like iPhone with iOS operating system or Android smartphones. Wow! So many devices, so many brands, so many vendors in one network. The question now will be, how do these devices understand each other? And how are they able to communicate to each other? The answer is OSI and TCP/IP models. What are these? These are two communications models developed by the ISO, International Standard Organization, and the DARPA, Defense Advanced Research Projects Agency, which is an agency of the United States Department of Defense responsible for the development of emerging technologies. These two organizations had come with two different standards, but they are relatively similar in many things, and they have small differences between them. Both standards released in the beginning of the 1980s, putting standard that all the manufacturers and operating system software development companies followed in order for their system to be able to communicate with any other device over any network in the world. These two models define clearly the rules that manufacturers shall follow to develop any device or network equipment. So all these devices talk the same language when they transfer data between them, whether they are connected on the same LAN or even over the internet. They are talking the same language. So, let's break down this network into pieces and dig more inside it to get more valuable information. The two PCs are connected to each other through a network cable called Ethernet, Cat6 cable. Ethernet is an IEEE international standard, consists of a group of technologies used in the LAN, enables the different network devices to communicate to each other. This is standard fully compatible with the OSI and TCP/IP model. This is standard developed in the beginning of 80s also, faced lot of evolution and revisions to increase its speed and distances through developing many technologies throughout the years. Its basic idea is to use a shared bus of different types of cables to connect the PCs together, using many data transfer devices on this shared bus. So, Cat6 cable is one of the cables used in the LANs, based on the Ethernet standard. Consists of 8 thin copper cables. Each two are twisted together to cancel the electrical signal interference between them, and they are called pair. So, Cat6 have 4 pairs. Each pair has different color: green, blue, orange, and brown. These pairs are separated by plastic separator to increase its performance and achieve higher bit rates up to 1 gigabit per second. There is a standard specification for the manufacturer of the network cables to follow in order to produce the Cat6 cables. Otherwise, the cables will not be used by the end users if they are not following this standard. This cable terminated from both sides with also a standard connector called RJ45 connectors. Similarly, any other device manufacturers like the network interface cards also, should follow the standard in order to be compatible with the Ethernet standard and used over the LAN networks. To produce a gigabit Ethernet network interface card with RJ45 connector and other specifications to be followed also by the manufacturer, like the transmission frequency, receive frequency, modulation types, and many other specifications. So, that's how any network equipment and even cables are made, based on the following rules and standards in order to build a LAN or WAN with compatible devices. As we saw before, building computer networks have a lot of benefits. One more benefit of using the network is the resource sharing. For example, imagine a company has many PCs in their office and there was no network to connect them together. Usually employees require to print many documents during the day. So, the company in this case should provide a printer for each PC, even if the employee may need to print only few pages per day. This is additional cost, which can be avoided easily by building a LAN and get one good network printer, so everybody can use it to print his document. This will save lot of investment and running cost. We will stop here for today to give you a chance to review the information given today. And please don't forget to subscribe to our channel or click on like if you find the information given today were useful. Goodbye and take care, future CCNA engineers.